Why you don't take my desires?
Nuclear energy. Energy found in the nuclear structure of atoms. Nuclear power is produced when a nucleus absorbs a neutron and splits into two lighter nuclei. This releases enormous amounts of energy, which in turn produces heat. Uranium is the most common element used to produce nuclear power today, and has an energy content about 3 million times greater than that of fossil fuel. Consequently, 1 gram of uranium is equivalent to approximately 3 tons of coal. Nuclear reactors harness the heat which is produced from the energy released when the atom splits and convert it into electrical energy. Nuclear reactions can change what element an atom is. A lot more energy can be obtained from suitable nuclear reactions than from chemical reactions. Uranium has 92 protons. 2 isotopes are important. U-235 has an atomic mass of 235, and U-238 has an atomic mass of, you got it, 238. Atoms consist of an electron cloud and a nucleus. The electrons each have the same mass and the same negative electric charge. The mass of an atom is given almost entirely by the nucleus, which consists of protons and neutrons. Protons have a positive electric charge and neutrons have no electric charge. The chemical properties of atoms are governed by the number of electrons in the cloud. These match the number of protons in the nucleus, and the electric charge of the electron and proton balance exactly. When an atom undergoes fission, it splits into smaller atoms, other particles, and then releases energy. It turns out that it is possible to harness the energy of this process on a large enough scale for it to be a viable way of producing energy. Nuclear reactors produce vast amounts of radioactive waste, including large amounts of very long-lived radioactive atoms. These radioactive particles are a product of the splitting of the atom. We are constantly exposed to low-level radioactivity from cosmic rays from outer space and naturally occurring radioactive isotopes, which in general do not cause any harm. However, at high levels of exposure there are numerous biological effects of radiation. These cause cell death, cancer, induction, and can cause genetic damage. The waste of nuclear reactors is highly radioactive and long-lived, and as a consequence must be isolated from humans for around 100,000 years. The current consensus is that nuclear waste should be disposed in secure containers and placed deep underground. We must remember, with great power comes great responsibility. The Chernobyl disaster is a great reminder of this, and we must remember it to ensure something like this never happens again. Nuclear energy. The future.